part 2, day 1, week 1. I'm going to start getting into the habit of saying that is first off, so that right when you click on the video, you can hear day 1, week 1. Or week 1, day 1, I think is probably the better way to do it. So we left off talking about the start. What were the last two of the slice? Stop and step, right? That's very important because this is weird syntax. And this syntax does apply to collection types outside of just strings. So if you want to do the same thing with a list or a set or something like that, you can do the : syntax in there. It's really useful. But right now we're just going to worry about strings. Okay, we're going to kind of change gears a little bit. So, and I'm going to erase this little line here because that's not correct syntax. And we're going to make sure before we get moving, I'm going to run my program. It's always good practice to run your program as many times as you can, especially while you're developing it, just because you don't necessarily know when things break if you just sort of code, and then you run it and now something doesn't work. You know, at any point in all of those coding steps, anything could have broken. So typically, I'll be working, and the minute I change something that I know like I can roll back, I'll run it to see if it works because I have to run my program over and over again. This might come as a surprise, but I think there's a propensity to not run the code until you're done. And I want to make sure that if you're feeling that sort of urge to break it, like the earlier you can break it, the better, is that run your code 1,000 times, 1,000,000 times if it's possible without breaking your computer. It's important that you always are maintaining what the state of your application is doing. And the most important state is that it's not crashing. It doesn't matter if it's supposed to show a 1 and it's showing a 0. Is that it's working or that it's running and it's not crashing is an important feature of an application. It is the number one way that I will send back. I will say you need to resubmit this as the number one way that you'll get it sent back to you. Is if I download it, install the dependencies, and I run it and it doesn't work, like it just crashed it, like there's like a syntax error. Like I sometimes like I know if it's close, I see a lot of work done there and there's like something stupid in there. I'll send it back to you and say, hey, just change this one line. But if you developed it completely in isolation and you never ran it, you said like, well, let me see if this works. I'll just send it and hopefully it'll work. That will definitely get sent back to you for no credit. So you have to resubmit it. So cool. So we talked about strings. We talked a little bit about numbers. I feel like numbers we could just keep going past. We talked about strings, a little bit about collections, slicing, and dicing, and all that cool stuff. But I have 2 more things that I want to talk about before this lecture is over today, and you can all go to lab. And that is going to be getting user input, and the other one is going to be comparison. And we're not going to talk about if or else or anything like that yet, but we're going to talk about things being equal or not equal, or being less than or greater than. So in order for us to be able to cover, and that's what we're going to start with right now. So in order for us to cover that, I need to tell you all about a new type. Because you have, so far we've talked about float, integer, and string, and kind of hinted at lists. But there's also a type of what's called Boolean. So there is a Boolean type. And the Boolean type is going to be true or false. And by the way, this is valid Python syntax. It's weird, but it'll work. It just won't do anything. So it's either true or false. And that means that it's a great, Booleans are fantastic because they're fast. They're very memory efficient because on the lowest level of the computer thinking, they're either a 0 or a 1. They're not an integer because an integer could be any number depending on what type of integer. It could be up to 0, from 0 to 64,000 or negative 32,000 to positive 32,000. Like that stores a certain amount of memory. But a Boolean knows that it's just storing a 0 or a 1 and it can't never be a 2 or a 3. So it knows it can store just 1 bit of memory for those. So they're very efficient and useful for making yes or no decisions. So for example, if I was to, how about this? I'm going to go ahead and I'm going to go across the 3 of you here. And I'm gonna say that my condition is that you have brown eyes, okay? And I'm gonna apply that condition to all 3 of you, and I want you to either say if you have brown eyes or not. I'm not looking at any of your eyes, so we're gonna start with John. John, do you have brown eyes? No. So his Boolean condition will be false. Kevin, do you have brown eyes? No, so his Boolean would be false. And Zach, do you have brown eyes?
False.
Okay, so we have 3 false evaluated conditions, 3 zeros. Not that you all aren't zeros, you're all heroes to me. But the thing was is that if I had some condition that said, if your eyes are blue, you get an A in the class and a certificate, or a brown eyes, and you get a certificate of completion in the class, then none of you would have gotten passed through that condition. So unfortunately, you have to go through the old-fashioned way, actually learn something. So what that means is that we can write a program that will act differently given certain conditions. So like if we have 2 numbers and say, hey, if this is an odd number, do this. If it's an even number, do this. In fact, one of the most popular, unfortunately, I say unfortunately here, one of the most popular coding challenges is very basic, and I'll tell it to you really quick. It says, if you have a number and it's divisible by 3, say like foo. And if you have a number that is divisible by 5, say bar. And if you have a number that's divisible by 15, say foo and bar. Like that is probably one of the most commonly used coding challenges. Actually, it's called FizzBuzz, but whatever. It's one of the most commonly used coding challenges to the point where if you see it now, it's kind of just like a joke that you see it. But like that's really heavily rooted in conditions. You can say like, I want to do some math, find the result. If it's this, say foo. If it's that, say bar. If it's either one, say foo bar. You know, those kinds of things. And it can go even farther than that, right? Like you can have crazy, like if you have a password, like user typed in this password, and user from the database had this password stored. Are those things the same? True or false? If it's true, I want to log them in. If it's false, I want to send them back to the error page. So Boolean logic is going to be everywhere. And it's very important for tonight's assignment because you're checking if 2 things are the same. So what I want to do is I want to show you how we can use, we can see if something is going to be the same in Python. And there's a little gotcha here, as there is with most programming languages, this syntax. So I want to print if 2 numbers are the same. Somebody throw out the first number. Just shout it out. 7. Now let's shout out another number. Somebody shout out another number. 23. Okay, so we have 7 and 23. Now this isn't valid syntax yet, so if you're following along, just kind of chill. Interesting, nobody shouted out 7 again. So what we want to do is we want to see if 7 is the same number as 23, which we're all smart people. We are way smarter computers than our computer is here. The computer's just a lot faster. We're better decision makers, and we're better processors. So we were able to see those 2 numbers. We were able to, in the back of our heads, compute that those 2 aren't the same, and we stored it for later memory. So what I want to do is I want to be able to say, hey, I need to make Python be able to make that same comparison without bombing out on me. So the syntax is to do 7 is equal to 23, which is not the same as 7 equals 23. 7 equals 23 is saying that 7 is now equal to the value of 23. It's like a Jimi Hendrix song, right? It's like if 6 was 9, then everything would just come crumbling down. So if 7 is double equal to 23, it would be the same as the first condition being your eye color and the second condition being brown. In this case, we're saying 7 is our first condition and 23 is our second condition. So when I run this program, we're going to see a false printed out into the interpreter output because that did not evaluate to true. Which is so weird. I'm like drinking broth as like my coffee here. It's like, good broth. Yeah, that does not taste like Sprite. So now we can check to see if 7 is double equal to 7. And that will evaluate to what you would expect is true. So you can see that our false and our true are showing up here as we would expect them to. For every action, there's a reaction. For every stop, there's a go, a to and fro. What we're going to do is now we need to say the opposite of something being equal, which would be if things are not equal. And so this one is a little bit easier to discern from the single equal and double equal because that's going to catch you every time. And here's a little hint. When you get to JavaScript, there's equal, equal, equal. There's a 3 equal, which is the best equal ultimately. But just know this, JavaScript 3 equals is the same as Python's 2 equals. And interestingly, both languages, single equal is the same thing. So an assignment and a comparison. So, and by the way, you can't do that. That's invalid syntax to do 7.
That's just like treat that as text and print 7 equals 7.
No, that will give you an error. So if I was to run this, it would say a keyword can't be an expression. Because believe it or not, every number in Python is reserved as a keyword. So like any number you can think of. Yeah, that's always something I like to give kids classes. Like, who thinks they can think of the biggest number? And they all start going crazy. 99, if they're like little kids, or like Google is the fourth graders like to say. But yeah, so every number is reserved. It's actually somewhat intelligent about how it figures out what a real number is. There's not some file that has like the number 0 through like 8 trillion or whatever. It says these are reserved. So it calculates whether it should or it shouldn't. But it's also the same thing as saying, well, no, you can say, well, I've never actually done this before. Yeah, so it's going to treat a string as a keyword as well. It's really crazy how it calculates it. But that is invalid. So what we want to do is we want to see if the two are the same. Because you can't just take a 7 and make it equal to 23. Like, interestingly enough, sidebar is that you all will get to know, is that in Python 2, you could use, this is one of my favorite little stand-up programming things, that you could set true to false. And so now whenever you typed true, it was false. And whenever you typed false, it was false. And so I would sometimes give this to new members on my team. This is back in the day because it's still Python 2. I would say, set true back to true. It's possible. It's very possible. It's a great little mind teaser for a junior developer to what they know about Python and setting things. Is that how would you get true to return true again?
False equals true.
False equals true. What is false now? True, and true is now false. There's still false. So true needs to be back to true.
Right.
True is equal to true. All right, let's see what that does. True is still false. This is more fun than I thought it was going to be.
True equals not true.
True is equal to not true. Somewhat poetic, isn't it? Yes, it's correct. That is one of the accepted answers. I used to bundle that up with some sort of like, some poetry and say, in order for you to retain truth, you have to realize that there's an untruth. All sorts of weird stuff about that. Then another way you could say is like when true is equal to false, you could say true is equal to true is not equal to false. So that's another way of, oh, wait, did I do that wrong? Is not equal to true. Sorry. Because true and false are the same thing. Wait, what? Oh, I'm screwing this up, aren't I? So when you have true and true, they're the same thing.
But if true equals true still keeps true as false, and it's saying false is not equal to true.
So that would be saying false is not equal to false here.
So
Then that would be true. But I don't know why I'll have to look that one up. There must be something weird going on. That one should be, as long as true is the same. That's like saying 1 is not equal to 1 is false. Like that should be set back. Oh wait, no.
you should just do true is not equal to true.
There you go. No, I need to say true is double equal to true. That will give you the inverse of it. So if I did that again, well, that's still fine. So if I set true equal to false, it comes back to true. Yeah. But you can't do that in Python 3 anymore because they were smart and said you can't assign to a keyword, just the same as you can't reassign to a number. That's like that will like very rarely come back to bite you. But if you're really into fun little programming tricks, which I hope you are eventually, as you start to learn more about this, you can do some fun stuff with Python 2 with that kind of logic. I have a little guide for you if you're ever interested in taking on the challenge. It's where is it? Come on. I think I called it Chaos PY. Wow, a lot of people. Oh, there's mine. There's mine. It's basically, I made a maybe class that reassigns, it randomly calculates true and false. So you can so it's like a new Boolean that is sometimes true and sometimes false. So here's the code to do it. But it's only Python 2. So, but then you can set true is equal to maybe, and then sometimes true is true and sometimes it's false. So just random crap that kind of keeps you busy. What's that?
Exhausting your own nonsense.
I think you got to have a little sense of humor, stuff like that. So anyway, let's get back to Booleans, and we'll get to user inputs, and then I'll let you all work on your homework for tonight. To say that something is not equal has a special syntax. We've already kind of previewed it. So I want to say that 7 is not equal to 10. That's bang equal, and that's another sort of, that's a programmer, I guess, typography thing, is that the exclamation point is sometimes referred to as bang. I think that's just a matter of exclamation point is 5 syllables, whereas bang is 1. And so you can usually get away with that. And you can run that, and it will evaluate to true. So really, if you have 2 items, the equivalency, this binary operation, it's binary in that it has one, right? One option is 0, or another option is 1. It's either true or false. You can also kind of see that there are 2 items that you're comparing. They're either true or they're false. There are more ways that you can compare things. There are ternary operations where you have like different outcomes based on it, but we're not going to get into those yet. So that's really all you need to know to see if 2 things are the same. So if I was to say like print Joel is double equal to Aaron. By the way, I use a lot of names from my personal life. So Aaron's my brother. You're going to get to know Aaron really well. Peanut's my dog, and Audrey is my cat. So and Sarah's my wife. So they're going to show up. There will be recurring themes through the class. And it was really weird in my last cohort. I actually had a student named Audrey. And so whenever I would be like, my cat, Audrey, I'd be like, not you. I'm not like singling you out. Like, this is my cat. And so if I was to run this, we would see that false. So you could put any 2 compatible types here. And you could even be incompatible types, right? Like, I'd say Joel is double equal to 1. What do you think will happen there? Like when we tried to add Joel and the number 1, it got all mad at us. But if I try to do double equals 1, what do you think will be? And remember that it's a comparison. I like this guy. Yeah, and it won't be an error, but that shows that you were listening. And I like people that listen. It will be false because those 2 items are not literally the same. But yeah, I wish it would be an error at this point. So you can check 2 different items to make sure that they're there, and if you can also check the inverse to make sure that they're not equal, which will return a true. So how you handle those is up to you. You can also assign these to variables. I can call this is Joel cool. That's is Joel cool. Or I can say that Joel is double equal to cool. So that's your syntax where on the right side you have the Boolean operation, and on the left side you have the assignment operation, where it takes the result of this expression, which is the same as this here. It's the same as this here. It's either going to be a true or a false, and then it will assign it to this variable, so that later on in the program's execution, I can refer to is Joel cool, and it will say no. It will say false. But it's okay. I think I'm cool. I got the dad cool thing going. All right, any questions on Booleans? It's always going to be a 0 or a 1, true or false kind of thing. It's a yes or a no. The way that you make it more complex is when you combine them. So you can say, like, I'll just briefly mention this, but it's not going to be appropriate for tonight's homework. We'll see it later on, though, is that I can say, if I want to print that x is double equal to x, and Joel is double equal to cool. So it's going to be false. But why is it going to be false, John? Exactly. So that's where you start layering complexity onto this comparison. So yes, we know that this is going to evaluate to true. So the left side of the and is going to be true. Now let's check the right-hand side of the and. That's Joel and is equal to cool. Well, Joel is not equal to cool, so it's false. And in order for an and to return true is that they both have to be true. Or they both have to be false. They just have to be the same. False and false, true or true. Wait, did I get that right? No, they both have to be true. They both have to be true for it to return true. If either one of them is not true, it'll return false. Which, like I said, like that's getting a little ahead. You don't need that for tonight, but just know that that's something that we're going to see later on, because we're going to be evaluating complex like ifs and else. So we can say like, if there's a vowel in the front of my name and my name is 5 characters long, we want to allow you to get in. You know, you could write a credit card number validator like with just that logic. You could say, because I think that there is, you know, from the first 4 numbers, you can tell if it's a MasterCard or a Visa. And so you could do that. You could say like, hey, I have my credit card number as a string, which is a really bad idea. Well, I guess you have to at some point. Credit card number is a string. What's the first 4 look like? Is that a MasterCard or is that a Visa? And you could just code that like today if you wanted to. So anyways, moving along here. So this, let's run this and make sure that this prints false. Yep, our last false there. Awesome. All right, one more thing. I'm going to make a big a visual line here. I'm going to print a big visual line. Like, you know, if you like ASCII art or something like that, this is, you can print ASCII art, like a little X swing or something like that, and it would show up. So here's our little line. It's a great way to make user interfaces just with print and, you know, stuff like that. I'm going to get some user input here. And there's going to be a couple of points that I'm going to make that are very important. First off, before we go anywhere, user inputs are always, always, always of type string. Even if I type in 23, that will be a string of 23. And just know that that will cause you trouble if you forget that. So if you try to accept a user input and treat it as a number, for example, week 2, we start coding up some like bank transaction type simulations. And if you want to make a deposit of $23 and you want to do something with that with math, like say you maybe need to calculate some form of penalty and you need to subtract it from 23 so that what eventually goes into your bank account. If you try to do that with a string, it's going to error out on you and you're going to be confused. So we need to, I'll show you how you can convert inputs eventually. Well, I'll show you today. But the most important part about user inputs is that they're always strings. Okay? All right, awesome. So in Python 3, and I say this because Python 2 is different, but we don't care about Python 2. Then Python 3, the way that you get a user input is with the input function, like that. So it's kind of like the print function. And a really cool feature of the input function is that you can get provided a string, and that will give you like the prompt that it will ask you before you give it information. So I can say, input, what is your name? So just with that, let's run the program, and we're going to see something a little different here. Notice that my program didn't just stop and kick me back to the terminal. What is your name? Now I can type in whatever my name is here. And when I hit enter, the program is done executing, because I don't have any code below here. So I would expect the program to do nothing after I type my name in. So what input does is that it halts the execution of your program. Everything is done. Well, not done. It's still running, but it's not running through any new information. It's not going to the next line. It's waiting for the user input. And so it's scanning the line until it gets a new line character that you've typed in with the enter key. And then it breaks out of the input and then it progresses through the program. So I want to be able to capture my name and say, hello name, you look awesome today, or something like that, you know, something silly. So I need to, well, okay, here's a quick pop quiz review of earlier today. I need to be able to store my name for later use. By later use, I mean like lower in the code. So how do I capture my name from this input? How would I do that? And a variable. Okay, so what's the syntax here? So if I'm on the beginning of this line, what should I type here? Just talk me through this. My name is equal to input. So after input is called, my name should have the value of whatever I typed into the screen, right? Okay, so let's run this. But I'll make sure that we didn't break anything in the process. Okay, cool. It still does everything we expect it to, but it still doesn't do what we want it to do. So right below here, let's just have it print out what my name looks like. What is your name? Joel. And it prints out Joel. Awesome. Okay, here's a quick refresher. What if I wanted it to print my name in reverse?
My name, Brian.
guys feeling confident with that answer? All right. Let's run this. If I said, what is your name, Joel? Liage, another Dungeons and Dragons name. That really was my Dungeons and Dragons name my brother gave me when we would go on campaigns together. Which I thought for the longest time, Dungeons and Dragons was just a way to like kill each other. Like I didn't really, because that's all my brother really did with it, is he would take me on a campaign and kill me somehow. And I didn't really realize that until I was older with friends that we played like at lunch that you were supposed to go on adventures and not kill each other. You imagine my surprise when I'm just like trying to act like my brother with my friends here. It's like I'm gonna kill you now, and they're like, wait, what? And they explained about playing it wrong all this time. Oh man. So my name reversed. Cool. So I was able to take my name in and reverse it. What would you want to do, like if I wanted to store my name reversed? A new variable. Okay, boom, right there. Stop right there. The word new variable came up. That's something that I always really like to point out, is that we are not paying per variable here. While you're in my class, if you have a good reason to assign something to a new variable, do it. Like, you're paying by the hour, not the variable. So you have enough, like, well, technically, from a computer science standpoint, you can only fit about 8 gigabytes minus operating costs within your computer. But your variables are going to be like 2 bytes, which in a gigabyte is something like a trillion bytes or something like that. So we got a ways to go. So if I want to make a new variable, okay, go ahead, John, sorry.
Create a new variable and set it equal to my name.
Wait, what? Okay, so what do I want to name this variable?
Reverse name.
Reverse underscore name is equal to my name. You said my name colon -1. Oh, interesting here. So here's a little programming quiz for you. When I print my name here, what will be outputted? Joel, straightforward, capital J, all that. And when I print reverse name, what would I see here? Sorry about that. Liage with a capital J. So why wasn't my name changed? Because I do this my name square colon colon -1 right here.
So you'll change that variable.
Yeah, the variables for reverse name, not for my name.
Exactly. Yes. And the reason I mention that is because that sometimes will trip people up. That's a common one. And I say that because there are ways that you can do that. There are ways that you can change a variable in place and not realize it. So we will get to those. Not today. Don't worry. It's a nice, safe coding environment today. But yes, that is a very strong thing to pay attention to, is that even though we have done this functionality to say my name in reverse, we didn't actually change what the my name variable was. We did, however, make a new variable. So yes, that carved out a new bit of memory, put that value in there. So now we have reverse name and my name, possibly right next to each other. Maybe they're distant cousins somewhere in RAM. But they're there, and they have their own values. But it did not change either the original value of my name. So when I run this program, what is your name? You can see that Joel and Liage kind of show up there together. Yeah. And so that's how you get input. Just input function, you call it, pass it a string with your prompt. Here's a question I have for you. My name is like popping up right against the question mark. That's kind of a bad user experience in my point of view. And I always like to think of the little things of the user experience. I know you guys got a lot on your minds because you're like changing your careers and putting it all on the line right now. But I will still continue to challenge you to think about the user experience, like to always to have the end user in mind, even if you are the end user. You know, we are sort of not going to go for that, well, I'm okay with that for now. Like, that's okay, but from the long term, we want to make sure what's the best here. So in my case, this right here is kind of annoying to me, where they're kind of like they're hugging. I don't really like that. So what is a way that you would keep the A in ACDASD from being right up on the question mark? Like, what could I change here about this?
Put a space after the question mark.
Put a space after the question mark. An elegant solution to an elegant problem. So yeah. All right, I'm going to show you quickly a quick way that we can kind of mess around with strings. There are methods on strings. I believe we have some of these in our reading. There's also available on Python 3 string. Built-in types. Whoops. Nope. No. I hate how it does that. I hate how it flies in there. So if you ever want to, if you're playing around with a string and you want, wow, that is old documentation. I guess it doesn't change very much. If you want to see all the cool things that you can do onto a string, no. These are all bad. What happened to this documentation? I want to do dot format. Not cap words. Okay, so I'm in the wrong spot here. Maybe it's in here. I'm pretty sure I linked to this in the reading today. Oh, here we go. Perfect. This is what I'm looking for. String methods. I'm going to link this to your Slack. This is what I'm looking for. So this will tell you all the cool things that you can do on your user input, like capitalize, or you could count subcharacters. That will really come in handy later. Not tonight, but eventually. Ends with will return a true if the string ends with the specified suffix. So if you want to say if this string ends with an E, it will return a true or false if it ends with an E. So what I want to show you here is capitalize. So because what I want to do here is let's close out of here and go into Atom here. And I want to capitalize the reverse name. Because the problem was that the J was capitalized because the user input, but I want the L to be capitalized on the reverse. So I want to type capitalize at the end of my reverse.name, and that is a method that can be used on a string, is .capitalize. So when I run this now, let's see what happens. Say Joel. I'll let you all type it up so you can watch what's happening. So reverse.name.capitalize. So that said, no matter what the user input was, even if it was capital J or lowercase j, it doesn't matter, it capitalized the first character. That can also be really useful to put here on .capitalize for my name. So if I print my name capitalized and reverse name capitalized, so if I type in lowercase j Joel, look at the user output. That is beautiful.
Is it smart enough just to capitalize it? It's not going to uncapitalize it if you type it capitalized.
I don't know.
It's not going to like flip it.
Let's see. I do know actually, but what I want to show is what my thought process is. If there's something I don't know, the first thing we want to do is we want to find out. So if we put a capital letter in there, the question was, will it uncapitalize it? The answer is that it will not. It is smart enough. But that is a great thing to bring up, and a great way to be sort of skeptical of the language is to, like, you might burn yourself out if you're always constantly questioning the language, whether or not it's going to break here or there. But it's a healthy mindset, in my opinion, to always be like, will this work if I do this? And then having the confidence to be able to execute it, to see if it does what you want it to do. You know, it's sort of that whole, if it doesn't work if it's 4, does it work 5 or 3 kind of thing. But you have all the tools to, this is sort of your sandbox, this is your playground to be able to test out if things work. If you're not comfortable making a change to your program because maybe it's like 5 methods deep and an if else, you can always just go into type Python, make a string, call it, or you can just even say like a string and call it Joel and then .capitalize. Look how approachable this language is here. I didn't even need a .py file. I just opened up Python. Let's see if I can even do reverse. Can I just do reverse? Would that work? No, there's no reverse. There is reverse D. No, I forgot about that. I think there's a reverse method. No, I guess I'm thinking of a different language. But you have a couple of requirements for tonight's homework. And I'm not going to sit here and spoon feed it all to you. But the answer to a lot of those questions might be in that link that I provided in your Slack. It's things like here. I think the one thing that is going to trip the most of you up is going to be able to get spaces out of a string. So how do you get a space out of a string? Because if it's a phrase like stunt nuts, right? That is a phrase that is a palindrome. That will not evaluate to true if you just flip it around. So you're going to need to do something with both versions to make sure that they can, before you check it, to make sure that they can be checked. And then if you want to attack the hard mode, how do you remove special characters like the apostrophe or a bang? Because if you just do a straight reverse, they're not going to. It's going to say false when it should. But yeah, there's a lot of cool things. Like if you can see, like if it is something, then that will tell you if the string, it will return a true or false if it meets that condition. So if we have a string of a number, you could say it's alpha. If it's alpha num, means if there's an A, B, C, or 1, 2, 3 in it, it'll say that'll alphanumeric. That means if there's like underscore or parentheses in it, it will say false if it's not alnum. Is numeric, is principal, is space, okay. Join, lowercase, that's lowercase and upper. So like if you don't want to just capitalize it, you want to uppercase everything. Or if you want to lowercase everything, it's a great way to clean it up to make sure that everything is the same. Replace is a really good one. Split, we're not really going to be using that one. Split lines, not really. Maybe a little bit later. Title does the same thing as capitalize, but it changes each individual word in a phrase. So if you just type hello world with the lowercase w and do .title, it will do hello world. So before we go, just a quick reminder. If I say x is equal to lowercase Joel, and I do, so x is Joel. If I was to do x, what is it? What was the one I wanted to do? Upper. What is the value of x right now? It's still lowercase. Always keep that in mind, that many of these methods, and there will be a time when we use a method and it changes the structure of it internally, but not today. Many of these methods will not alter the value of a variable. So if I want to capture Joel as all uppercase, I would have to I would do one of two things. I would have to assign it to its own variable, like x upper is equal to y, so y is equal to Joel, or I could do the x dot upper right there in the Boolean check. So I could say y is double equal to x dot upper. What do you think that's going to be? True? True. Because y is double equal to x dot upper. All right, so we're at 2 o'clock. This is probably the longest I'll ever keep you for a lecture. I don't think I've ever kept a lecture past 2. So, and I know we started at like a 1:10, well, we started like later than that, didn't we? We started like 1:15, 1:20. Yeah, so okay, we're good. Okay, I hate keeping students longer than they should. But yeah, I wanted to make sure you all had all the tools that you needed for tonight's homework. So at this point, I'm going to stop lecturing. I'm going to stop the video. Wait, and before I turn the video off, are there any questions about anything that I've covered, about the homework? Okay, just want to make sure. Yet. Well, you will have questions about the homework possibly, but they won't be captured on the audio.